Okay, this is page 14 in your interactive notebook of Module 12. Now, we are going to be representing algebraic relationships now. So we're going to be graphing them and we're going to be analyzing them. So our word problem, starting up here, Angie's walking speed is 5 kilometers per hour and May's is 4 kilometers per hour. Show how the distance each girl walks is related to time. Okay, so time, if you're looking up here, I would, for myself, if I'm trying to remember my independent and dependent variables, I would remind myself that X is time because it's independent, and Angie's distance is going to be Y. And over here for May, time is still independent, and May's distance is also Y. It's the dependent variable, okay? And also think about, I'm not sure which or classes I talked about my half marathon, but time was constant. But as I went on during my run, my speed got slower, but time doesn't change, okay? So this is the start of the race, okay? And at 1 hour, she had run 5 kilometers, which is pretty good. At 2 hours, she had run 10 kilometers, okay? And so what they're doing, and then over here with May, started the race. At 1 hour, she had run 4 kilometers. At 2 hours, she had run 8 kilometers. Now, what they want you to do is for each girl, make a graph showing her distance Y as it depends on time, X. Plot points from the table and connect them with a line. Write an equation for each girl that relates Y, distance Y to time. Now, in this situation, if you were to continue the graph, I would recommend you finish your table first. You need to ask yourself, how do I get from X to Y? Well, we know 1 to 5 that we're increasing. So that means we have to go from either operation of addition or multiplication. So I know we like to start with the addition first. So if I go from 1 to 5, I have to add 4. So 1 plus 4 is 5. Is 2 plus 4 10? No. So now I know that I'm not going to be doing addition. I'm going to come back here. How do I get from 1 to 5? Well, I multiply by 5. So I'm multiplying by 5. Let's test it over here. What's 2 times 5? 10. So 3 times 5 is 15. And 4 times 5 is 20. That's a lot. That's a lot of running. Now May, 1 to 4, let's start with addition again. 1 plus 3 is 4, but 2 plus 3 is not 4. I mean, 2 plus 3 is not 5. Goodness, Collins. 2 plus 3 is not 8. It's 5. So we know addition's no way. But I'm going to multiply by 4. That's what I'm going to go with. By 4. So 2 times 4 is 8. So I know that this relationship, multiplying X by 4, is going to give me Y, May's distance. 2 times 4 is 8. 3 times 4 is 12. And then 4 times 4 is 16. Now come down here. You need to plot her points. We've completed the tables. Now we're going to plot the points. So everybody is starting, both girls are starting at the origin, the starting line. Okay? Remember, our origin is 0, 0. So for Angie, 1, 5. So I'm going to go over 1 and I'm going to go up 5. And you got to kind of gauge that scale there. In 2 hours, she has gone 10. 3 hours, if she keeps going at this pace, she will have gone 15. Quite a girl there. And at 4 hours, she has gone 20. Now looking at May, we're plotting her over 1 up 4, over 2 up 8, over 3 up 12, over 4 up 16. Okay. Now, we need to make up an equation. Well, we know that X is constant. We have X. Well, we know that Y is dependent upon X. And we decided that X times 5 was going to give us Y. So y equals x times 5. Now remember, we are 6th graders, so we're going to put our coefficient 5 in front of our variable x. So 5 times x. For May, we decided that y being dependent upon x times 4 is going to give me y. So y equals, remember, we are 6th graders, coefficient 4x. That's how it should look. Now, down here, we need to analyze this relationship. How can you use the tables to determine which girl is walking faster? Can you use the graphs? Oh, they're walking, not running. Excuse me. So, there's a couple of ways you can do that, okay? When we look at the tables to determine, in my first hour alone, Angie has walked 5 kilometers. In her first hour, she has walked 4. So looking at that, well, just from my first hour, you can tell that Angie has walked further than May. But if you continue on with my table, at every hour, Angie is just a bit more ahead of May. And by my 4th hour, Angie has walked 20 kilometers and May has only walked 16, okay? And this is something I want you to put in your own words. I'm talking about it with you, but I want to see you put this in your own words. How can you use the graph? Okay, this one's a bit different. We have not talked about this yet, but what you would do is attach your points. Make a line with your points. It doesn't have to be perfect. But if you look at your lines, whenever we're measuring speed and we're looking at a linear function, this is a linear function, the steeper your line, meaning, I'll do this. Steeper your line, meaning the taller it is, the closer to being up and down it is, the faster something is, the greater something increases. And when it's laying down closer this way, that means it's slower. So if we were to look at our 2 lines right here, you could tell that Angie's line is a little bit steeper than May's line, meaning you can tell that Angie is walking faster than May. So do the analyze relationships, put it in your own words, okay, put your ideas down, and once you complete this page in your interactive notebook, go to the next page in the next video.